Hello, everyone. Thank you for making the time to join our webinar. We are very excited today to share our work regarding the automation of structural engineering processes. I am Mohamed Adil. I am a structural engineer and a software developer. I have participated in the design of multiple high-rise buildings in Qatar. And recently, 4 years ago, I shifted to software development where I worked as a full-time in multiple startup and corporate business. With me is Cal. Carl, you can introduce yourself. Kel?
Yes, thank you everyone for joining in today. I'm Kel, I'm a structural engineer, and I've been working with Arab for the past 4.5 years, and we have mainly developed several timber buildings throughout Europe. And I'm quite excited about this project because it really combines my passion for structural engineering, but then also for programming as well. And in this tool, I have primarily been responsible for the connection design.
Great. It's unfortunate that Musaab Mahjoub has some recent urgent reasons and he couldn't join us, but he is also a structural engineer with extensive research in timber connection design, where he helped us a lot with this application. So the structure of this webinar is simple. We're gonna tell you about the what, and then we're gonna tell you more about the why, the problem, and then we're gonna speak more about the solution, how we did it. The easiest way to explain what Awatif is by showing an example. So Awatif is the first web-based parametric structural engineering platform. So it is a platform that helps you build structural engineering apps like this. So you can build a building, an arch bridge, a truss, a reporter frame where you can change the mesh density, and in real time you can see the actual deformation or the simulation happening in real time. And you can also visualize the forces, the internal forces like the bending moment in this case, in a 3D viewer. You are not restricted to do only the boring static analysis, but you can also do some fancy dynamic simulation if your requirements require to, like earthquake engineering or impact simulation. It is possible with the parametric environment as well. And you don't also need to stick with 2D drawings. You can do 3D structures like this truss, where I change here. In this case, I'm changing the point load at the top, and you can see the deformation are happening in real time. The most app that we are proud of is the Truss Designer, where we automated all the workflow from the modeling until the reporting, but we will dig more in this after Kel introduce the problem that we're solving.
Yeah. So as I'm still in the industry and I'm doing these calculations on a daily basis, I would like to give you sort of the current workflows, an overview of the current workflows before we jump into the live demo. So nowadays, it's basically a manual sequence of different design steps involving multiple programs with different licenses. So that means that for each workflow step, the data has to be transferred manually from one program to the next one. So throughout the lifetime of a project, this cycle has to be done numerous times, which means it's very time consuming, and then there is a lot of room for error as well. So now with more digital solutions, especially with the help of Rhino and Grasshopper, they try to connect the different workflows. So especially Grasshopper acts as a center player, enabling a data stream between the different programs. So this is obviously a very good development where the engineer becomes the digital architect themselves. However, these solutions tend to become quite complex as they are done quite quickly on the project, and therefore they're also not very accessible for other colleagues. So the Awatif Trust Designer aims to tackle these challenges. So in a world with projects with an increasing complexity and with higher sustainability demands, it's necessary to design quicker, more in detail, and more efficient and sustainable. So these automated solutions become increasingly more important. So that's why our approach is to unify and combine the entire design process basically in one software. So from the FE analysis to the connection design, to the report as well, and then lastly to the export of the geometry. So this wouldn't be possible, obviously, for any type of generic structure. So we have basically focused on one specific type of structure. So in this case, it's a timber truss, which enables us to improve this specific design process. Yeah, one more aspect that I would like to mention is basically that we think the engineer should always remain in control of the design process. So basically, this approach of hybrid modeling is quite important for us. So you can do it parametrically, sort of like automated, or there is also possibilities where the user can input it manually. Yeah, and then lastly, one more aspect is basically, so since it is a closed cycle of information, basically within one software, we have the detailed information about the quantities. So we know exactly the lengths, the volumes, and quantities, and therefore we can compute, for example, the carbon footprint of the entire structure.
Great. So now, since you know what is the problem, the way we solve it might sound a bit new. Why we didn't stick to the traditional approach of using Python or sometimes Dynamo or Grasshopper? With Awatif, we want an application that is web-based, so it's easy to share your application with your colleagues. And also, with web-based application, you are not requiring the user to install expensive hardware. They can just open the link. And another important aspect that we want in Awatif, it is a script base. If you compare it with the visual programming tools like Grasshopper or Dynamo, they are great for simple application, but as soon as the complexity increase, you ended up in this spaghetti model, which are very high, which make collaboration very difficult, and it's also not maintainable. But with a script base, it's easy to abstract the concept in different files and folders. You can easily test different components, and you can also use version control system like GitHub, where multiple people can work at the same code base. Another important aspect that we value very much is open source. So you have full control of your application. Nothing is hidden. You can add, remove any kind of features. You have the full control in your app. And also another important aspect that we want to push our industry to take it in a more serious manner is the collaborative work. So, for example, the design calculation that we did for the timber connection or the member design, they are already open source. They are designed to the Eurocode and for timber, of course. And since they are there, they are open source. It's validated by us. It's tested, and other people can just use and plug and play. So, imagine if we all collaborate and work in this kind of tools and building this kind of script. It's not only calculation script. You can also build your logic, like the Truss logic. It's also applicable open source, and you can just plug and play. To give you more example to understand exactly what we're doing, here's the Truss Designer app that we were talking about. You can visualize it in 3D. As you can see here, you can change the span, you can change the height, and also you can change the topology, which is also important. Here I'm changing the topology of the truss. And in real time, you can see the loads are applied. So here I'm applying a point load at each, as you can see them, at each node on the top. And as soon as I change the point load, the deformation are happening in real time. You can also look at the internal forces. It's not just the geometry. Let me untoggle the loads. Here is the normal forces. And if you increase, let's say, if you change the span, you still get the deformation, the topology. And as we mentioned, it's not only modeling and analysis, it's also design. So here we doing timber design for the members. And let me just return the notes back. As you can see, if I reduce the force, the more colorful it's become. But if I increase the force, they will tend to exceed the limit, which is 1, the utilization ratio in this case. Same concept is applicable to the connections, but in this time, the visualization is happening at the nodes. I'm going to increase it a little bit. If I decrease the loads, you can see the nodes start. Here I'm increasing the loads, and the nodes are starting to fail one by one. Finally, the most important aspect of your truss, or I mean your design, is the report. So for the report, I will hand the mic to Kel to explain you more about the report.
Yes, thank you. So moving on to the report. So the report basically is important to check and validate the calculation results of the structure. So the way we build it is, so basically here we have a global table So here you have an overview of all the beams, basically all the geometric properties, the actual force. And then here you can see basically an overview of all the checks that's been done. So what Mohammed just showed you on the nodes is basically for each node, the maximum value for each of these nodes. Yes, so since we have basically the full control of all the quantities, what we can do here is to compute, for example, the embodied carbon. So in this case, yeah, the result is that we have timber elements with the length of 104 meters, which accounts for basically an embodied carbon for 1,430 kilograms CO2 equivalent. And the same for the fasteners. So in this case, it calculated 1,100 fasteners. So this is a clear benefit as we have the full control over these quantities. So since we have also an overview of these checks, we can now have a look and see which node is critical in terms of the utilization. So we can now then go into the node. So here I have selected the node number 4, and it visualizes the connection. So the way the connection designer works is it automatically calculates the amount of fasteners that are required to achieve sort of the utilization factor of 90%. So it automatically calculates the amount of fasteners. So that's why as you change certain values, it basically also adapts the amount of fasteners. So this is also drawn in 3D, so you can have a look in detail. So it's a sheet connection. As you can see, we have 2 sheets in this case. And yeah, so here you have a little summary table as well, an overview of the checks that are shown in proper calculation formulas at the bottom here. So the report is structured so that we have the input parameters. You can use these drop downs to have a look at the calculations. They're all done after Eurocode 5. So we have the fastener properties. Also very important are the spacings. So we have the timber and the steel spacings, and then basically the maximum out of those two is the final spacings. Then we have the fastener capacities with the different failure modes that are required in Eurocode 5. And then lastly, we have the connection design and the member design. So basically for the fastener check, it automatically calculated the amount of fasteners that we need. So then we have the check for the fastener, and then we also have a check for the metal sheet themselves. And then quite important is that, so since we have holes drilled into the cross section, it's important to use basically the effective area. So this is quite critical, and some engineers don't do this correctly. But yeah, you need to erase basically the holes that are required for the fasteners and use that for your stress check. And then in this case, we have a tension check, but then in case you have a compression check, the stability check is required as well. And so what I've shown you before in the graph is basically to close the cycle of the workflow. We are now working on implementing basically the geometry export. So what you have seen here at the top, so we would have this for the entire structure. So the result, exact amounts of fastener and everything for the entire structure can be then exported as a DWG. So you can use that for your Rhino model and for any other purposes as well. So then, this cycle of design is done within one software. Back to you, Mohammed.
Great. So we have a lot to show with our platform, but we just need to give you an example what is possible with Awatif, and the Truss Designer is just an example. We can automate multiple kind of project that could be like a high-rise building, a warehouse. It could be like a simple task like the distribution, let's say, of pile foundations. It could be like a canopy staircases. If you have any interesting project that you want to automate and save some money, reach out to us. The easiest way is to connect with us in LinkedIn. We are very approachable. You can find the link at this slide. And finally,